good afternoon, everybody. This is a joint tech session, a tech talk session between the Oregon chapter of the IEEE Communication Society and the Society for Information Management Portland chapter. So by way of introduction, the program chair for the SIM Portland is Jordan Musanga. You want to say a few words about SIM Portland?
So my name is Jordan Musanga. I'm the CIO at PERS as well as the program director at SIM Portland. So SIM Portland is a collective group of professional CIOs as well as IT leaders in the Portland metro area. So thank you for joining us tonight.
In my role, I have a double hat. I am the Oregon chair for the IEEE Com Society, as well as a trustee for the SIM Portland board. Right, I was a former president and current trustee, and with that, I like to introduce our presenters today. And all right, the two of you are now in spotlight, so the floor is yours.
Great, thank you, Pradeep. Let me start sharing the screen. Yeah, so let me get started. Hi, everyone. It's good to present in front of accomplished set of folks here joining the call. So my name is Sunku Ranganath. I'm one of the solutions architect in the Smart Edge team at Intel. Been with Intel for over 11 years now, and been working on many of the telco, telco core and telco edge services side of the world, enabling reference architecture and solutions, working with customers. So our topic today is unleashing services at the edge. But before that, let me invite Sindhura probably introduce herself.
Thank you, Sunku. Hello, everyone. It's nice to be here today. I'm the solutions architect as a Sunku in the Edge segment group in network platforms division at Intel. And I have been focusing on the edge computing and ecosystem enabling for our project called Smart Edge Open, which we'll talk today. And I've been working with the ecosystem partners mainly to create the edge solutions on the Intel architecture and scaling through with the through their platforms. Thank you, Sunku. Over to you.
Yeah, thank you. Yeah, so maybe let's see if I can move the slides. Great, so here's the brief high-level agenda. Let's talk about why edge services are different from cloud services or cloud functions, how they're different versus, so the platform that we have, a Smart Edge platform, how it enables a lot of these functionality at the edge. And then we look at some of the experience kits and use cases as to how anyone can apply some of the concepts at the edge across various verticals, various industry segments, and talk about application onboarding and a couple of things, a few things that anyone could do. All right. So between Sindhura and myself, we would alternate. And if anyone have questions, so please do feel free to stop us while we are sharing, because I think the content we have a good 40 minutes or so content. We'll try and complete 30, 40 minutes. So yeah, please do feel free to stop us as we go. So yeah, one of the first things that that needs to be clarified, rather many people that we interact have a different perception or conception of what edge is. So one of the first things I like to clarify, right? So there are different types of edges, basically, right? So one way to look at edge computing, right? So it's the Internet of Things side of where a lot of devices, whether it's your smart meters or PC, cell phones, laptops, tablets, all of them, you can say, on the IoT side, a set of devices. The edge that we are focused, right, is somewhere in between the devices to the cloud data center or the network core of telecom service providers, right? So there are multiple layers in between that constitutes the edge, right? And broadly, you can say two major types: on-premises edge and network edge. So your on-premises edge consists of your, so before I share what these are, so the primary goal of edge computing is bringing compute processing power close to the end user, close to the devices, close to the where the application is user of the application is running these services on, right? So from the traditional aspect of running applications in the data center close to the user, there are multiple tiered architectures that that constitutes of edge essentially. So on-premises edge is sort of devices or an area where you deploy the compute power, processing power at the customer premises. For example, universal customer premise equipment where you can run your firewalls, your access to wide area network, or your right, so your border network gateways. So some of these things constitute on-premises edge. Right, set-top boxes it was in the past, like in customized set-top boxes was an example, but now with the move towards standard off-the-shelf compute, so it's all of these are virtualized or it can run in containers. Other examples are like smart factories where you have a set of devices, connected robots or connected devices, and they need a set of processing powers like analytics or a device-to-device communication using infrastructure. So all of that can be on-premises edge. And there are different verticals, right? So transportation, which is your connected cars, so V2X communications, or in the healthcare field, right? So smart hospitals, smart retail floors. So all of these, you need a set of compute power at the premise before it can go to cloud. So that you can say it's on-premise edge. And then you have network edge, where latency here is about 10 to 40 milliseconds. On the on-premise edge, depending on the use case, latency, round-trip latency, communication between end user and the device function is anywhere from less than 1 millisecond to less than 5 milliseconds, right? So the network edge, you can broadly say there's access edge, where all of your base stations, radio access network, right? So a lot of that type of edge can come under your access edge. With 5G, there are many more use cases being enabled because of the softwareized components and the distributed nature of the 5G deployments, right? So that constitutes your access edge. And then there is near edge, which is your virtual central office or next-gen central office type of deployments. It's called near edge because it's near to the actual network core from a communication service provider, right? So Verizon, AT&T of the world from their perspective. And then your regional data center, for example, your content distribution network, where this is heavily geo-distributed. So that constitutes sort of your regional data centers. So across these edge computing platforms, one of the important factor which is what is enabling innovation in this space is lower total cost of ownership. Right, so the services to be enabled and the automation at the edge. So lower TCO is one of the driving factors to enable these edge platforms. And almost all of the industry is moving towards a cloud native platform approach. So in terms of distributing applications into microservices, away from virtual machine type constructs into container constructs. And the orchestration, resource management a lot across these edges, right? So the middleware and services. So enabling them have been much more easier in the shift towards a cloud native set of platforms. And one of the de facto orchestration software or management software that is popular today in the industry is Kubernetes. And managing these platforms and infrastructure, Kubernetes is being heavily customized so that it's suitable across these edge computing platforms. So one thing I do want to touch upon is how are you classifying edge services versus cloud services, right? So what is unique about edge in terms of these service offerings. So on the right, you see a picture from the specification put forward by ETSI, European Telecom Standards Institute, which has a MEC industry standard group, which is multi-access edge computing. It used to be called mobile edge computing, now rebranded it as multi-access edge computing. So the majority of the edge deployments, edge platforms are looking to conform to the set of specifications put forward by ETSI MEC. And the primary reason being operators and service providers across the world, right, across different continents have come together and say, hey, these are the set of components that our edge services need, a set of rules, requirements, how the applications scale across boundaries, across geolocation, right? So the platform, the MEC platform that they put together, have a set of rules and interfaces, a set of requirements, so that you can easily do lifecycle management. You can easily do onboarding, so that multiple vendors can do interoperable services deploy across these MEC platforms. So in that sense, MEC is the most popular industry standard for edge computing right now. So now when you compare this to cloud services, right? So what are set of tenants, key architectural tenants that one needs to consider? One of the first one is mobility versus scalability. In a cloud data center type environment, so you can assume that so you have close to unlimited type of compute resources. So if one node fails, one resource fails, you have a high availability type instances. You can scale down, scale up, right? So it's all microservices based scalable architecture. In terms of edge, though, you need to consider mobility as the primary factor, right? So let's take an example. You have a VR headset, virtual reality headset in a vehicle that you're sitting and that's traversing across multiple regions, touching upon multiple base stations, right? So the same application needs to be extensible across time, across different geolocations, and be able to offer low latency type delivery, right? So the video delivery. So mobility, how would your service application go across these boundaries, right? So that's one of the key aspects that ETSI MEC kind of put forward from mobility perspective. And then resiliency versus redundancy. So again, redundancy in a cloud, high availability or scaling resources, or you have load balancers where you can scale across your services in the server side. So the redundancy is a common thing there. Here, given the resource constraints, right? So maximum you have maybe one node server to maybe 10 compute nodes, right? So at the edge, you don't have unlimited resources. How are you doing self-healing, auto-healing, right? How are you scaling? So a lot of those architectural aspects come into play in terms of resiliency. And then edge native functions, cloud native functions. CNFs are pretty popular right now in terms of enabling microservices-based applications. Now, when you customize that to edge native functions, right? So the latency and distributed nature of the edge and data locality, all of these come into play for edge native functions. There's a good paper written out by Carnegie Mellon University that first they coined the term edge native functions. So that kind of provides attributes of what these are, ENFs. Right? And then the next three, heavily distributed tiered architecture, data locality, right? So if you go back to this picture, one of the key important aspect of edge is data closer to the end user. So across these different layers of edge, the data locality has to be maintained. Right? So if you don't need to send the data to the cloud, rather do the processing at the edge location and provide the insights, provide the responses at the edge, instead of so adding latency to communicate to the data center. So data locality, the security aspects here, and then the tiered nature of these applications, right? So you do minimum processing here and then send to the next edge location where you can do rest of the processing and then to the cloud data center, right? So the applications have to be aware of this tiered architecture styles in order to be able to leverage the edge, distributed nature of the edge. And then latency, of course, right? So the whole goal of enabling edge computing is to provide low latency services. Right? So the services need to be aware of latency, like for example, your storage requirements or your, the image of your service that you want to deploy. What are the resources that it needs, right? So the as minimum as possible to deploy at the edge. So all of these form, the key aspects of edge services. Any questions so far? Okay, I'll move on. So having said that, what are set of challenges across Edge? And if Edge is so good, why isn't that everybody's already moved on to Edge and start writing and start using Edge services or Edge applications, right? So some of the key things that we see in the industry that and things that we are solving are with respect to resource constraints, right? So given you have limited set of resources, how do you optimize? How do you manage your services distributed across Edge, right? So that's one thing. High network performance, right? So data plane performance for this distributed nature, either within a smart city environment or a smart building environment, right? So the network requirements, depending on the day, time of day, or number of users, so it has to scale seamlessly across these bandwidth changes, bandwidth requirements. And then policy management, right? So for the service that you would deploy, what is a set of policies? Right? Should it scale? Should it die? If it doesn't meet the constraints, right? So all of these user policies and usage policies come into play, and seamless scaling between edge to cloud. And one of the first thing, if you go to AWS or Azure or GCP, all this cloud, and they would say that, hey, it's the same API that you can use across edge to cloud, right? So that's one of the key components, a common set of APIs. So you don't have to reinvent your services again and again across these different infrastructure. Security and privacy, right? So we were just briefly touching upon this. Security has been a key tenet because now if you have a private data center or your public cloud, it's all heavily firewalled across because the infrastructure is controlled by a set of folks. Now moving to edge, right? So the target area, surface attack area is much wider because the infrastructure is heavily distributed and a lot more users are accessing it. And then how do you control the data privacy? Right, so authorization, authentication, accounting policies, how do you customize that? Right, application onboarding, you have new app that you develop, new service, how do you deploy it and scale it? How do you do GitOps and DevOps, right? Onboard the application, that's another one for the distributed nature of the edge. Lifecycle management, right, so bringing up, scaling it, killing it, right, making space for next set of applications, all of this come into play. Public versus private cloud. One of the common trend we see is enterprises using private cloud infrastructure within their environment, within their enterprise environment, and then leveraging public cloud, for example, for edge. Right, so scaling across seamlessly between both. And hardware abstraction utilization. Now, given the distributed nature and low latency, high performance needs, hardware abstraction play a very, very important role. And we do want to ensure application services utilize hardware accelerators, right? And utilize the abstract APIs that abstract the hardware accelerators. So that's key. And artificial intelligence, machine learning models. So this is very pervasive today at the edge. This is more at the edge, more companies, more revenue models, more innovative service models are being developed using AI/ML for the edge. And of course, automation, right? So you have tons of these clusters at the edge. You cannot have admin per location, right? So you need pretty much 2 to the power of X number of administrators to manage this. So automation is really important. So to provide a set of solutions across, right? So provide a common platform to indicate or to ease anybody to onboard their applications on an open platform, right? So the Intel team came up with Smart Edge Open platform. So essentially, it's an edge compute software toolkit that is heavily modularized and a customized version of Kubernetes deployment. And given the nature of the fact Kubernetes is more like a Lego pieces, you can divide it across, based on your requirements. So Smart Edge Open brings together a lot of the components that are needed for, this low latency communication or security or scalability, right? So with the microservices-based architecture, so that user can consume the platform as a whole, right? You can deploy this on a server of your choice, and the Smart Edge platform and infrastructure is ready. Or you can pick and choose some of the building blocks that are available in open source, so that you can customize it for your environment. Some of the key features, for example, KPIs for Edge, key performance indicators, high throughput, low latency, deterministic performance, quality of service tuning for your use case, at low jitter, security. So all of these components that are needed within Kubernetes environment already pre-packaged, so that you can use it across multi-location or multi-access, multi-cloud. It's compliant with the HCMEC architecture and the other industry standards, for example, 3GPP, which put forward our cell phone standards, 4G, 5G standards, and ORANs, which is Open Radio Access Network specification from the industry consortium. So it's compliant across all of these industry standards, and it provides a set of reference architectures, experience kits, set of reference implementations that we'll talk about today to give an example of how Smart Edge Open addresses some of these use cases across different types of edge, right? It's built on CNCF components, so the Cloud Native Computing Foundation. There are a lot of projects being enabled, so it leverages the best of these projects and build a common framework. So to dig in one level deeper, right? So what does Smart Edge Open mean? So it has a Kubernetes controller and a Kubernetes edge node. We call Smart Edge Open edge node. So for anybody who is looking to use this as and deploy their application, write their application, right? So those applications and services are deployed in Kubernetes pods. Okay, for whatever reason, it went out of present mode. Let's see. So you can deploy your application in Kubernetes pods and containers. Seamlessly, you can transition across platforms. And Smart Edge Open provides the required hardware accelerator interfaces or container networking interfaces, CNI aspect, or the pods and the telemetry. Right? So a lot of those components are already installed out of the box for you. Right, so that you can get going with your application enablement instead of worrying about infrastructure bootstrapping or infrastructure management. And you can easily onboard and manage your applications with similar to how you do it in the cloud. It's tailored for these type of edges, right? Access Edge, on-prem edge, network edge, right? And it's open source. One can look at the code, contribute to it, or leverage it. Right, so it can build easily utilize some of the components of Smart Edge Open. And what are the building blocks? So this is the key part, right? So that's that is what making Smart Edge Open very popular across different edge providers or edge application enablers, right? So underlying, you have Kubernetes components like for telemetry or visualization or DNS, or Docker, API management, etc. Now the building blocks with respect to multi-access edge, right? So you need to be able to provide the required networking for accessing across different types of edges. So that's included. Then your resource management, right? So how do you scale across your memory, compute resources, hardware accelerator resources, your GPU, based on whatever use case that you want to use, use case AR, VR, or say scaling this video inferencing, or facial detection. So all of these are compute intensive. How do you scale the resources automatically, right? So the interfaces are provided. So analytics with respect to AI and ML, right? So the required toolkits to deploy your own. Let's say you have a custom machine learning algorithm for vehicle detection. How do you deploy it and start using it across the building that it's the edge infrastructure is deployed, right? So that's the analytics part. High performance data plane. So Kubernetes infrastructure provides a lot of components like Calico, Cilium, a lot of these CNI interfaces. And then there's a service mesh, which offloads a lot of layer 4 to layer 7 connectivity, circuit breaking, and health checks of applications. A lot of this offloaded from applications into a service mesh. So Smart Edge Open provides automatically deploys a lot of this for you. So you can, out of the box, you can start using. And zero trust security, right? So the idea behind here is none of the components, right? So it may be administrator, may be the individual applications, may be user space, kernel space functions. None of them can be trusted, right? None of the users can be trusted. How do you deploy, scale your APIs right, with zero trust? That's one. And wireless and acceleration, we touched upon a couple of these. Service chaining, this is more pertaining to network functions. Like if you have for example, a border network gateway, okay, for example, your broadband type deployment, you have your firewall, you have your deep packet inspection, you have your WAN, SD-WAN type connectivity. All of these need to be service chained so that you get optimal performance. So how do you dynamically manage that from cloud, right? So you have that access. And of course, telemetry monitoring to see what's going on in the infrastructure, what's happening in the applications. One of the common use case we see here is green edge, where you're sensitive to the power requirements, how much overall power you use, frequency or voltage. And how do you deploy and scale these power requirements? Let's say it's busy in the morning and no one is on the street at night. So how do you dynamically scale the compute resources when it's a busy street versus when it's night and you don't have to do a lot? All right, so a lot of that carbon footprint analysis and green edge computing is incorporated into the building blocks, Smart Edge Open. Any questions so far? No, okay. So yeah, with that, I'll hand over to Sindhura to talk about the next set of topics.
Thank you, Sunku. So as Sunku explained until now, we now know what the building blocks of Smart Edge Open are. And some of these are packaged as kits called as experience kits. So each experience kit is for a specific use case. And so think of it as more like a packaged Kubernetes cluster. And the first one to our left is the developer or engineer experience kit, where it is the baseline of the experience kits. And it is a location agnostic, so it can be deployed anywhere. And moving to the right, we would see different types of experience kits for different areas of the network edge, like Sunku described before. And each experience kit is highly focused on the use cases like UCP or private wireless or ORAN for the AccessH and so on. So in additional to the Kubernetes plugins, operators, enhancements, and so on, these platforms are built with a common set of building blocks. And then we built a framework which is the Smart Edge Open, so that we can pick and choose these building blocks, which can be assembled together to form an experience for a use case. Yeah. So if you want to, if you have a specific use case in mind, and you can try that specific experience kit to deploy on your solution, or if you want to just try it out, then I would start with the first one, the developer experience kit. Next slide, please. So as I said, this is the basic experience kit, and it's a basic Kubernetes cluster with many Intel invested projects included in it. Like, for example, you might notice many known projects in here, like Calico, or SRIOV support for high performance CNI, or node feature discovery, topology management, CPU management, or core pinning, and all the telemetry components which enhances the Kubernetes cluster, and which gives you a good platform framework for your edge solution deployment. And this experience kit is validated on Ubuntu, and we have validated it on a specific OEM hardware for now, but various others will be coming soon. But this is validated basically and on an Ice Lake platform as of today. And we are making it easier to deploy with the provisioning, which is we are using another open source project called as Edge Software Provisioning, which makes it easy to deploy the whole package on your server. So it's a basic starting point if you want to try out Smart Edge Open, and you want to try out the edge computing on the Intel architecture platforms. Okay, now going into a step deeper. This is another experience kit we have, which is called as 5G private wireless experience kit. If you want a cluster capable of running a full RAN stack, like L1 layer, L2, and L3 layers in it, with a DU, the CU, the 5G UPF, 5G control plane, with edge applications, if you know the whole 5G stack, it starts to get complicated, like UE connectivity issues and so on. There are so many things to be working together, and so many complications to be resolved to make everything work together. So we put together a stack to hit the right level of performance for end-to-end private wireless scenario. So we built this using Intel FreqSTAN, which is the DU part, and the CU part, the UPF, and the control plane are from a third-party vendor called Redis, and we'll be having more commercial vendors and applications here. So some of the issues you might run into when you, for example, integrate the RAN and core part on an Ice Lake platform, we have solved some of these issues and put it together as an experience kit so that you can just deploy it and have a private wireless running on your server, and you can just deploy your application on top of it, and it's a months of effort saved for you. So, for example, wireless spec is fairly complex, and additional with the FPGA and EA6 support, it is even more complex. So we have implemented the Kubernetes operators for that, and similarly the OpenVINO for AI support. Next slide, please. Yeah, another such experience kit, just to give you an idea of what we have, is the AccessH Experience Kit, which is basically a full ORAN stack we have released the DU portion of it, which is, if you know, the 5G stack, which is the most complex of the stack. And the number one concern for DU on a Kubernetes cluster is how we are going to achieve the determinism, like to ensure there is no packet loss, or to ensure there is minimum jitter and so on. We have a full white paper on the Smart Edge Open website describing how you can achieve this determinism from an I/O platform acceleration and orchestration standpoint. I would highly recommend. I'll highly recommend everyone to go through it, and it gives you all the different knobs you need to turn very precisely to be able to run a full DU on a Kubernetes cluster. And yeah, it's an experience kit if you want to easily deploy the DU without any performance or determinism related issues in your stack. Next slide, please. Yeah, so we have this
question.
Yes, sure.
This is Rath from Intel. One question is, like, you mentioned the determinism is kind of, supported. What is the level of determinism, for an example, in terms of, I don't know, latency or packet dropping, something? What is the range of determinism supported right now?
Yeah, we do not have the performance numbers per se. I would say the exact latency or the jitter, but that falls in the acceptable range for the AccessH at the network. And it also depends with the vendors, right, which we use as the later part, like including with the CU and the UPF and so on. But as I said, going through the white paper will give you a good idea on what we have been working on.
Okay, so the capability is there, but the ranges and things depends. Okay.
Exactly.
Thank you.
Right. So the other way to look at this is, right, so you can deploy a lot of this. So essentially providing the underlying infrastructure in terms of Kubernetes or your DU pod. Now, the numbers with respect to the latency, right? So the round trip latency or the scale of the number of users that you can access, that the DU can handle, right? So without a loss of data. So all of those aspects are heavily dependent on the stacks that you use, like Sindhu mentioned. So one can use the simulated version of the RAN stack, RAN components, or actual, the physical box for some of these RAN components that you can deploy these pods on. So yeah, so from an experience kit perspective, providing the infrastructure. Now, once we start getting into the actual numbers, like the FlexRAN is a good example. I think there's a lot of material published with FlexRAN as to how, so what are the benefits with respect to performance data that we can look into.
One quick follow-up question. So as part of this, a Smart Edge Experience Kit, what kind of stacks, is that stacks are there, or that the developer needs to put everything or something in there?
Yeah, so Sindhu, yeah, can share.
Yeah, I think if I understand your question is, do the developer need to put it together, or is it all packaged together for the developer? Am I right?
Right.
Yeah.
Correct.
Yeah, so the part of bringing experience kit is for the same reason. We have let's say stitched it all together, improved it for the right performance and all the KPIs, and put it together as a stack so that the developer just needs to take it as a kit and deploy it on the server, just run a single step and deploy it on the server. And he'll have all the full stack together, which is then easy for them to port their applications on top of it.
Okay, thank you.
Yeah. Okay.
Any other questions? Okay.
Great. So now we have talked about experience kits until now, and we are also offering some reference implementations along with experience kits to basically get a feel for how how running an application on top of these experience kits look like. These are basically the reference implementations we have here are basically IoT applications which are already validated on the developer experience kit or its Smartage Open, and they give you a feel for how the application works on top of the Edge platform. So the ones we have here are packaged in Helm, and they are basically the containers which are available for download, and you deploy it on the developer experience kit and see what's possible with each of the use case. Like we have one for intelligent traffic management, and one for the in industrial for the PCB defect detection, and so on, and for healthcare and immersive media and so on. We'll go into a few of these in depth next. But we have multiple of them, and I would encourage to go to the link at the bottom, which is the Intel Edge Software Hub, and download some of these RIs and applications and just try it out for yourself. Okay, and the first reference implementation I'd like to touch base is with the telepathology reference implementation. Just to give you a background on what the problem is and why we have started to look at it, is the forecast demand for global pathology is expected to be at 11.4% growth by 2025. And almost all the pathologists are, most of the pathologists are in US, and where there is only 4.3% of the world population. So this as the need increases, the medical field is seeking to enable higher productivity of the pathologists. So which can be achieved by improved peer or specialist collaboration for diagnosis and getting faster results with efficient processes. So as of today, without digital pathology, the sample slides of the cancer tissues are physically shipped to other doctors to get a second opinion, which automatically introduces the latency in the process, as well as there is a risk of the physical damage for the slide or the data itself. So, and the other challenge, another big challenge we face today is digital pathology is challenged by multi-access network that is either wired 5G, 4G, or 5G Wi-Fi, and so on, where logic is needed to properly route the data, and security is utmost importance in healthcare and cannot be violated. So this is to move data between the hospitals or send it to a consulting or collaborating pathologist. And also another problem we see was the image transfer. The images itself might be up to 80 gig of uncompressed data, and transfer of this, if it's digitalized, and transfer of these digital images between the hospitals or within the hospital has been a major problem, as we see. So we proposed a solution with two of Intel's open source components called OpenVino and Smartage Open, where OpenVino is used for optimizing inferencing algorithms, which is applied to the digital pathology compute workloads, and Smartage Open is used to solve the networking needs. So this POC uses a digital pathology workload example to showcase how an optimized software architecture can simplify and automate the networking challenges, and also automate AI model deployment and management within an hospital system. As you can see in the slide here, it's a pathology platform we have created. as a reference architecture, and the sample slide is scanned and analyzed by the slide scanner on the left, and that information is then sent to an image management system or patient EHR usually. And then at this point, the analysis would take advantage of the OpenVINO capability to efficiently run the inferencing. And then the pathologist in hospital 1 makes the diagnosis and sends that information to a viewing pathologist, let's say in hospital 3, for consultation from another hospital. And at this point, the smart edge network abstraction and security and other 5G microservices would enable them to efficiently and securely transfer the data to the viewing pathologist. And then the usual process is the viewing pathologist also examines it, makes the diagnosis, and sends the results back to the first hospital. And the first pathologist then reviews the consultation and sends the info to be uploaded to the patient's EHR. So we have implemented this as a reference implementation just to give the sense of how openness and smart edge open can work together in a healthcare use case. Okay, and just to I'll just go through few other reference implementations we have here. I'll not go in depth as the previous one, but just to give you an idea of what exists today. So we have another application called or reference implementation called Immersive Media, where it is a video analytics pipeline based on the Intel distribution of OpenVINO Toolkit, and also a DL streamer. So the media streams can be forwarded and analyzed through the distributed pipeline. It's a Kubernetes-based deployment, like all the other ones we have on the Smart Edge Open DEK platform, and it can be either a single node, 2 nodes, or multi-containers. And it also contains an enhanced Android player to receive and process the analytics metadata, and also has a web UI for the simulator. The main advantages for developers and end users, I would say, with this RI is the work on real-time video stitching for 4K and 8K after the VR camera input. And also they work on H.265 OMF encoding format, which supports high and low definition mixing. And they also work on the field of view support for dynamically switching to HD. Next slide, please. Yeah, another healthcare use case or reference implementation we have been working on is the telehealth remote monitoring, which is quite common or quite famous use case for the past 2 years, I would say, because remote monitoring the patients across the facilities or when at home has been increased. And this RI is basically enabled by cloud native containerized WebRTC server sessions, and they are hosted between the users so that they could include all the interested parties like clinicians, patients, caregivers, and etc. at one session. It is a web-based interface, and it provides a way for the users to connect, view, and communicate from a range of possible endpoint devices, including either cameras or phones and laptops and so on. So after getting your hands on with the reference implementation, you can directly integrate the components from Intel Collaboration Suite for WebRTC and Open Visual Cloud, which is another Intel's open source project, which is a pipeline for pipeline of building blocks for real-time video analytics. Next slide, please. Okay, so the last RI I would like to discuss today is the industrial one, which is the printed circuit board defect detection. It has a sample demo application where the reference implementation is enabled for detecting defects in the components assembly in a factory environment. The IP camera will usually record the video of the assembled boards moving over a conveyor belt, and then the IP cameras will stream the video to the EIS, which is the Edge Insights for Industrial pipeline, and the video processing applications, namely like a video ingestion or video analytics, time series analysis, etc. They happen using the RTSP streaming protocol. So the captured video is analyzed and filters out the selected images for further defect analysis. The video file used in this demo is sent from the camera stream pod as RTSP stream. And this EII or the Edge Insights for Industrial PCB Defection will have different types of application pods, 5 application pods, as you can see on the DEK Edge nodes. And the EII is basically the Edge Insights for Industrial is basically a set of pre-validated ingredients for integrating video and time series data analytics on the edge compute nodes. So these are the RIs, just to give a glimpse on what we have as of today. And as I said, you can hop onto the Intel Edge Software Hub and check out the RIs and come back to us if any questions.
There's one more RI before we close out an RI. Yeah. 5G smart roadside infrastructure or smart roadside units to say. Now in this example, this was put together by Intel team and Capgemini team. So in this example here, you have a busy, excuse me, busy intersection. And so the idea here is intelligent traffic management to avoid collisions or detect or predict collisions or distribute the traffic services like your red lights or pedestrian walking time, for example. So detect that in real time and change or predict or intelligently suggest some of these operations in real time. Right. So the example here, we have multiple video cameras that are detecting in each frame. They detect whether it's a car, whether it's a bicycle or a pedestrian, right? So or unknown object, unidentified, alien UFOs, whatnot, right? So this is where you would run OpenVINO server, for example, where you run your inferencing on your video streams, and the capability for it to kind of predict the speed, right? So depending on how the particular vehicle would cross in multiple subsequent frames, you can identify the speed of the vehicle, for example. And based on that, you could run analytics at the edge and leverage the 5G radio connectivity and have a method to kind of dynamically adjust or control your traffic management infrastructure. Right, so some of the hardware infrastructure, software components involved in something like this. Right, so from an administrator perspective, all you would need is a single web interface where you could simple dashboard. You could look at the analytics across this. But from infrastructure at the edge, you need, for example, a Xeon-based server and software ingredients, for example, from Capgemini here, the platform as a service offering called Ensco on Edge, which takes care of the software management at the edge, software radio, right? And then you have a VPU, HDLR accelerator. VPU is a visual processing unit that can run your OpenVINO AI applications. And you can deploy all of this using, for example, Smart Edge, right? And from a 5G stack perspective, you have your FPGA for acceleration, layer 1 acceleration, 5G, G Node B in this case, so the 5G standalone, or you can have 5G new radio, right? So a lot of these components, 5G components or 4G components deployed at the roadside unit. And then you have connectivity to the cloud using, for example, here, Capgemini and Scone platform. It leverages a lot of these Smart Edge building blocks that we were describing to deploy these applications at the edge and have them connected to the cloud. And the applications here is running traffic metadata. For example, in the demo that we've done, stream traffic metadata for V2X here, vehicle to vehicle or vehicle to infrastructure type communications, and your AI processing applications, right? So if you look at them one level deeper, as a lot of those would run within a Kubernetes cluster. You have your visual compute processing applications, and then you have 5G connectivity, 5G layer 1 or 5G user plane type applications. And you have a bunch of microservices based on Smart Edge open running, right? So it takes care of a lot of your networking issues, like with network interfaces, SIV, Kubernetes, edge networking, right? And then accessing the MEC runtime with the app registry, containerized application platform and its management layer. So a lot of this is automated in that sense, using the edge platform as a service type of solution. And you have connectivity to the cameras, for example, your Ethernet, and then 5G radio is connected. A camera device can be wirelessly connected, right? 5G camera. So you can enable multiple ways of deploying this at the roadside infrastructure, and then dynamically at runtime, and do this automatically, right? So you don't need someone looking at what's happening at that intersection. So a lot of this AI models run this automatically. And of course, like when you have 100 of these intersection, the amount of data is incredible, right? So the good thing at the edge, you're processing a lot of this data, and then you're sending off to the cloud the end result, or the inferencing, right, that was done. So you could this type of infrastructure automatically call 911 for ambulance. If there's an accident, if there's a fire, call fire station, right? So a lot of that can be automated in types of these deployments. So in terms of service models, right? So we saw some of the use cases, right? So based on your usage model, based on your industry, there are multiple service models that you can enable, or you can develop, you can enable, you can provide. Right? So in simple to say, right, so the application agent, edge application agent takes care of a lot of this. That is a part of the Smart Edge component. Right? So you have generally speaking, you have one producer, one client consuming like what producer produces. And at the edge, you need a lot of these service discovery, like different components that are dynamically coming up, going down, service discovery, notification management, subscription management, right? Service management. So a lot of that, for example, you could use something like a Kafka, where you can have multiple publish, subscribe type events going on across the hundreds of these devices. Or IoT side, MQTT is a popular protocol. That's another way to run MQTT on this edge platforms, right, between client and producer. So given the underlying infrastructure is taken care, so it's easy for any application that leverage data from these, right, so services, MQTT or Kafka, right, so you can subscribe to that, and your application, it's pretty simple to kind of leverage what's there. So you can onboard your application, utilize the AI or hardware acceleration that's already available, and then customize, leverage the network infrastructure, right, for DNS or network policies, right? So it's already out there that you can start leveraging. And then, of course, data security. There are a lot of work. There's a lot of work going on right now with respect to Secure Guard extensions that provides enclaves where you can, for data to be applications to utilize these enclaves, so that even the administrator who has access to kernel space cannot use that, right? So that's one. Then data privacy, data, encryption, decryption at scale. A lot of that, hardware acceleration for a lot of that is already taken care, and you have APIs to leverage that type of usage models. And then, of course, API support, so that you can, as an edge service provider, you can have a simple API support. Smart Edge Open provides that for you. So I think before I go on, there's one question in the chat. Could Edge replace or supplement CDN, a content delivery network? CDN is also a type of edge model, right? So for example, when we click a YouTube video, one of the first things it accesses is the cache in the CDN. So now you can leverage the existing CDN deployment, the video network already, the video cache from CDN already, and you can leverage some of the other edge type constructs, like depending on the location, you can customize the ads. Depending on time of the day, you can deliver optimized services on top of your video services, right? So based on the edge type of deployment, you can work along with your CDN network in order to deliver optimized services for the user. I hope I answered the question. Please feel free to unmute and say so if you need more details. So another question is, how do you see 3D body scans primarily for the apparel industry being leveraged by Edge? I can provide, but maybe Sindhura, do you want to take a stab at it?
Yeah, I think we have something similar to this as we have a commercial part of Smart Edge Open called Smart Edge Classic. And we have demonstrated something called similar to this, where we have a video or emoji detection of the users that come in to buy clothes, whether they're happy with the clothes or whether they're sad or something like that. But the Edge plays a critical role in there, where they have servers in there in the floor itself, and they have the data stored in there, and it's used to primarily give the reactions within just few milliseconds with very less latency. I would say that is an interesting use case from the industrial vertical as well.
Right. So to build on that, right, a lot of these use cases, what you need is a camera where you're looking at the end user, analyze the end user, whether it's moving vehicle or a person's reactions, right? And a lot of compute power is necessary in order to use machine learning algorithms or AI to detect some of these at the edge, right? So, and that's what edge infrastructure on-premise, for example, your retail store on-premises can help do that, right? Using various sensors or audio, video sensors. A lot of processing can be done right there, so that you don't need cloud type communication. You don't need 3 seconds for the user is waiting to see, like, hey, what would cameras tell me back, right? So you can do it in a matter of milliseconds. So, so 3D body scans and also being able to change the apparel on a person, which I think I've seen an ad for that too, right? So that a lot of this is much more easily enabled by Edge in that sense. Thoughts on avatar hacks being a considerable Edge security concern? Yeah, yeah, that's sort of the first questions you get asked in that sense. Yeah, Sindhura, I know you're working on security side of things, right? So maybe you want to share.
Yeah, I think some of it starts at the hardware level, where you provide security from the PKI perspective, or or the enclave perspective itself, but regarding the avatar hacks itself, I actually I'm not sure. We have not looked into it, but that's an interesting use case to go look at.
Yeah, so the what matters here is the privacy of the individual, right? So the person who's being the video stream that is recognizing the person, right, without identifying the person's name or without someone else accessing the person's information, right? So that's where this data privacy comes into play. And today, what you have with Kubernetes, for example, right? So the role-based access control, or the NIST has put forward next-gen access control. So who's accessing the data? What are the authorization policies? How is the authentication set in place? And how is data locality, right? So where is this data stored, right? Is it on the edge server? Is it being sent to a cloud where someone can intercept? Right? Is it scaled across multiple instances or multiple nodes have it? What kind of administrators are accessing this? Right? So abstracting this personnel data with the management of the edge infrastructure. So that's where there's a lot of security being kept in place. Right? Your traditional firewall and network gateways and all of that is primarily for networking, overall networking, great. But now with the application-specific, data-specific security being put in place at the edge, right? And that's what is differentiating. And some of this, from a hardware perspective, we are leveraging hardware root of trust models, right? Where that particular platform is verified to be deployed on specific location-based access security, right? So if an application or user from another location tries to access that data, they're denied because it's outside of that trust boundary, right? And then there is zero trust policies, where no one is provided free access. No element, no software entity, no hardware entity is provided a simple access, right? So it adds, some of these adds latency. So there's a hardware acceleration for it, right? A lot of this data is encrypted. So you have a quick assist technology where it can accelerate encryption, decryption, compression, decompression, for example. Definitely the security at the edge is the number one concern, and there are a lot of application service security policies being put in place. And the policies are the key part here that play an important role in terms of security. Right, so I hope I kind of provided an idea there. So if no further comment there, just a couple more slides about to be towards the end, right? So for anyone who's using like the underlying infrastructure, right, Smart Edge Open, hey, I want to develop an application. Now I want to showcase some of the cool technology, AI, ML, or wireless network type applications, or whatever applications you have. How can you help share it with the rest of the ecosystem? So like Sindhura mentioned, there's a commercial version, Intel Smart Edge Classic, so that you have, where you have a Edge portal, application portal, where you can onboard provide your application, host your applications there, so that Intel can refer them for your specific attributes of your application. And the benefits there is, you can accelerate time to market, taking the functionality and reaching out to customers in ready to deploy fashion, and Intel's ecosystem of partners and so the publications, marketing efforts, like it's a lot of that you can leverage using a partner programs. And it's a lot of hardware, software optimizations already available for you, so you can leverage that to build a robust edge portfolio. So here's a simple example of the portal that is available. You can check out commercial applications, network builder portal. And a lot of companies have enabled their applications, Kubernetes for Edge CDN, for example. right? So there are Altran for radio access network, Radisys, right? So there are a lot of different types of vendors have enabled their applications there. So, so my last slide here. So now that you know a lot of these, right? So what can you do? Right, so look at some of the use cases that that are important for you, right? So in the beginning of the call, we were discussing, like, hey, what can be the use cases? So essentially, whatever you're doing in cloud, see how it can be done in the edge, right? And that's the benefit of edge, right? You don't need a private data center for every use case that you can think of. How can you leverage edge in the public cloud, private cloud, and our private edge, right? You don't need to go to hyperscaler again for every use case that you have. And our team is happy to chat with you further on any of these use cases. You know, if you're you know, happy to deploy and try it out on a machine, on a server, you can try out Smart Edge Open platform, Developer Experience Kit, like Sundar alluded to, or expanding on existing use cases, start developing applications on top of Smart Edge Open. And of course, our team, we are pretty active in standard bodies like HCMAC or 3GPP, right? And defining, shaping the future of edge computing, right? Industrial consortia like Open RAN, Open Network Foundation, it's pretty active there, defining the 5G or beyond 5G type use cases. And open source software, a lot of this Kubernetes related CNCF ecosystem, a lot of components are open source. And companies are moving towards packaging this open source and deploying for their platform. So there's a lot of traction across the world for open source software. You can see how you can leverage that. Of course, the whole platform is for open collaboration. I'd say there's a lot of work that's been done in terms of enabling these. So yeah, welcome to get back to us for any questions. Yeah, so with that, I'm pretty much done. So open it up for questions.
Yeah. Thank you very much for the presentation. Let's see, do we have any more questions from the audience here?
It looks like either everybody understood every single detail that we shared. Or
all experts.
Yeah, no one knows anything. No one understood anything.
Okay, all right. If there's no other questions, thank you again for presenting tonight. And for people who want to reference the video, should be up in the next couple of days on the respective sites. All right. And with that, thank you all, and have a very good evening.